So now, as we have understood that how to draw a frequency polygon curve with using histogram. So now we'll see how to draw a frequency polygon curve without using. So next part we'll see is frequency polygon curve without using histogram. So without using histogram, how to draw a frequency polygon curve in that case. So we'll directly see one example based on this. Let's take one example. First we'll note down the data in the form of table. So this table consists of marks the students got in the exam. Let's take between 10 to 20, 20 to 30, 30 to 40, and let's say 40 to 50. These are the marks, and accordingly the number of students are given. 15, let's say 10, 12, 18. So these are the number of students given whose marks are between 10 to 20, 20 to 30, 30 to 40, 40 to 50. So now accordingly we'll see how to draw a frequency polygon curve in this data. So as we are without using histogram. So as we have seen with histogram, first what we need to do is we need to draw a histogram, and accordingly we'll take the midpoints of the histogram and join those midpoints to make the frequency polygon curve. But in this case we are not drawing histogram, so definitely we directly need to take the midpoints of the bar that we have drawn in using histogram. So how to do it is in this type of case, what we'll do is we'll directly find out the class marks or midpoints of marks given. So and accordingly we'll plot the graph using those class marks on the basis of the number of students. So first we'll find out class marks, and for finding out the class marks we have already seen that the formula for finding out the class marks. So class marks can be found like lower limit plus upper limit divided by 2. This will give us the class marks. That is, for 10 to 20, how to find out the class marks is 10 plus 20 by 2, that is 30 by 2, that is 15. For 20 to 30 it is 25, for 30 to 40 it is 35, and for 40 to 50 it is 45. So in this way we need to find out the class marks when we are not using histogram. And now accordingly we plot the graph on the basis of this. So first we'll note down the points 10, 20, 30, 40, 50, and accordingly we'll take, and so these points are actually the class marks. These points actually represent the class marks. So this is the one way like we can do. We have taken the class intervals here actually 10 to 20 to 50. But as we know, class marks are different. So if we want, we can directly take the class marks also, or if we want, we can also take the class intervals also. In that case, there will be no difference in the graph. So these are actually the class intervals I have taken, or sometimes we can also take here as class marks. And this is actually again the number of students on the y-axis, that is frequency. So accordingly we'll take the points here 5, 10, 15 and 20. So now for class marks 15, as we see the number of students are 15. So as we know that 15 will come between 10 to 20 class marks, and number of students are 15. So accordingly we will take points between 10 to 20 at 15. Now second point in the class marks is 25, and accordingly the number of students are 10. So 25 will come between 20 to 30. So accordingly we will take 10 here. Then the next point is 35 and 12. 35 between 30 to 40 and 12 just above 10. And accordingly 45 and 18. 45 and 18. So in this way we need to take the points, and accordingly now we will join these points to complete our frequency. So in this way we have joined these points, but again this frequency polygon curve is incomplete because as we know that it is a polygon, so it is definitely will be a closed frequency. So definitely we need, what we need to do is we need to join their starting and end point with the x-axis to complete this frequency polygon curve. So just so our main first class was 10 to 20, and accordingly the midpoints of that is 15. So accordingly we will take the previous class of 10 to 20, that is 0 to 10, midpoint is 5. So as there is no number of students between 0 to 10, definitely frequency in that case will be 0. So we'll take this point on x-axis and accordingly we'll join it. In the same way, we will take the next class of 40 to 50, that is 50 to 60, and accordingly we will take it the midpoint, that is 55. And again the number of students are 0, so we will join it with x-axis. So in this way our frequency polygon curve has completed. So these are the points which we have marked here, and by joining these points we have actually completed our frequency polygon curve. So in this way we need to draw the frequency polygon curve when we are not drawing histogram with it, that is without using histogram. So it is just a similar way of doing it, but the difference is that in that case we use histogram, and in this case we don't use histogram. So in this way we need to draw the frequency polygon curve without using histogram. And now we move on to the next part of this chapter, that is measure of central tendency. What do you mean by measure of central tendency? Measure of central tendency means actually to find out the average of the given data. So for finding out the average of the given data, we generally use three types of measures, that is mean, median and mode. So all three are the method to find out the average of the given data. But there are certain cases in which we need to find mean only, and so there are certain cases in which we need to find median or mode only. So we'll see here like when to use the median, when to use mode, and when it is required to find out the mean. So mean is generally help us to find out only when the quantity is given, that is when the numerical data is given. If the numerical data is given, then we can find out mean, median, mode, anything. But mean can be found only when there is a numerical data given. If the data is not numerical, or you can say suppose the quality of something is given. So if the quality is given, it means the data is not numerical. In that case we cannot find mean. In that case we only find either median or mode. Like suppose if I take any example, like if I given let's take quality of 3 students in a class. Let's say one student is good, other one is very good, and other one is excellent. So if I ask like what is the average of this group in which the student is good, very good or excellent. So if I need to find out the average of this group, I cannot use mean here because the quality of the students are given. Quantity is not given. So as the quality is given, so definitely we cannot find mean. We can find median or mode. So if I ask the average of this group, definitely the average will be very good of the group of a group of 3 students. So it means I have find out the median here. So so that's why the median or mode are required also when the quality of the something is given. In that case we cannot find the mean, and mode definitely, as we know, is find out for the thing which has the maximum frequency. So definitely there are different uses for mean, median and mode. So first we'll see what do you mean by mean and how to find out the mean. So generally mean can be find out, or average you can say, basically the average, the mean can be find out, that is sum of n observations divided by number of observations. So mean can be found, suppose if the numerical data is given, you need to find out the mean. What we need to do is we first take the sum of all those observations and we divide the sum by the number of those observations. So accordingly we will get the mean. Let's take one example here. Like suppose if I give the data like let's say 10, 12, 15, 18, 20. So suppose this data is given and we need to find out the mean. So what we need to do is we need to take some first thing is sum of n observations, that is sum of 10, 12, 15, 18 and 30. So this is the sum of observation. We need to do the sum of this divided by the number of observations. So now as you can see here the number of observations are 5. So it means we have to divide it by 5. So now we'll solve it. So if we add all this 10, 15, 18 and 30, what we'll get is 85 divided by 5. So if we add 10, 12, 15, 18 and 30, 20 and 30, what we'll get is, so after adding this thing, what we'll get is, we'll get 85 divided by 5, and when we do 85 divided by 5, we'll get is 17. So this is our mean. So in this way, we need to find out the mean, that is sum of observations divided by number of observations. This is the method of finding out the mean. But this is the case when the numerical data, individual numerical data is given. But sometimes there is a case when with the class marks the frequency is given. Let's take one example here. Let's take one more example here. Suppose the data is given like this here: class marks and frequency. Let's say class marks are given 10, 20, 30 and 40. Let's say frequency is given 2, 3, 4, 5. This is the frequency given. So in this case, how to find out the mean? Again, as we know that there is only the one formula for mean, that is sum of n observations divided by number of observations. So what to do is, in finding out the sum of observations, what we need to do is, we need to add this numerical data. So as you can see from the table that class mark is 10 and frequency is 2. It means 10 is appearing 2 times in the numerical data. If 10 is appearing 2 times, it means we need to add 10 2 times. So instead of that, what we'll do is 10 into 2 plus 20 is appearing 3 times. So what it means, we need to add 23 times. So instead of that, what we'll do is 20 into 3 plus again 30 is appearing 4 times, that is 30 into 4, and 40 is appearing 5 times, so that is 40 into 5. This we need to do to find out the sum of observations. So if we solve it, what we get as 20 plus 60 plus 120 plus 200. So this will get the sum. So if we add it, what we get is 400. So this is our sum. So now how to find out the mean in this case? So mean is, again as we see, what will be the mean? Sum of observation, which is equal to 400 divided by number of observations. Now how to find out what will be the number of observations is, as you can see in the data that 10 is appearing 2 times, 20 is 3 times, 30 is 4 times and 40 5 times. So it means this whole data will give us the number of observations. So for finding out the number of observations, what we need to do, we need to take the sum of frequency. So if we take the sum of frequency, that is 2 plus 3 plus 4 plus 5, what we will get is 14. So this will be our number of observations. By taking the sum of frequency, we get the number of observations, because as 10 is appearing 2 times, so it means there are 2 observations, 20 is appearing 3 times plus 3 observations, 30 is appearing 4 times plus 4 observations, 40 is appearing 5 times, that is plus 5 observations. So sum will be 14. So mean is sum of observations divided by number of observations. And accordingly, if we find out what will the mean in this case, we can easily find out. So important thing here is how to solve the problems, and most importantly is to understand the problem. So to understand the problem, it is very necessary to observe the problem properly, and accordingly we'll get the mean. So if we find out the mean in this case, what will be 28.6 approximately. So in this way we can find out the mean. So for finding out the mean, we also use this formula in this case, that is sum of fi into xi divided by sum of Fi, where I belongs to 1 to n. 1 to n. N means the number of observations. So according to the number of observations, we can easily find out the mean in this case. So Fi xi means, so for finding out the sum, what we have done here, this class marks is generally represented with x and frequency is generally represented with f. So what we have done here, we have taken the product of x and f, that is 10 into 2, then 20 into 3, 30 into 4 and 40 into 5. We have taken the product, that is Fi xi, and accordingly we have done the sum of all these things, that is summation, is representing that after taking the product we need to add those all things. So after adding it, we will get the sum of observations, that is summation of Fi xi divided by summation of Fi. So summation of Fi representing the number of observations which we have done here. That is, we have taken the frequency as 14. It means what we have done, we have added all the frequencies, that is summation of Fi. And n is the number of data, number of different data. Like in this case, in this example, n will be 4 because there are 4 different data, that is 10, 20, 30 and 40. So there are 4 different data or 4 different class marks. So in this case now n is 4. So accordingly this is the formula for finding out the mean. So now we'll see some examples based on this. First write down the example is, suppose mean of 6, 4, 7, P and 10 is 8. So find value of P. So in this case, it is data is given in which the mean of 5 observations are given as 8, and among these 5 observations, one observation is missing. So we need to find out that missing observation. So how to do it? Again we know that there is only one formula for mean, that is mean is equal to sum of observations divided by number of observations. So in this case, as you can see, mean is given. So mean given is 8. Sum of observation is 6 plus 4 plus 7 plus P plus 10 divided by number of observations, that is 5. So now we need to find out the value of P. So what we'll do is, first we'll cross multiply, that is we'll take 5 to LHS, or we will take 5 to with 8 and we multiply it by 8. So we'll get 8 into 5, that is 40, is equal to, we'll add the remaining numbers and P will remain as it is. So 6 plus 4 plus 7 plus 10. So we will get 27 plus P. So after adding 6 plus 4 plus 7 plus 10, we will get 27 and plus PL will remain. So again what we will do is, 40 will take 27 to LHS part, it will become minus 27 is equal to P. So therefore value of P is equal to 13. So in this way we need to solve the problems by understanding the problem. And most important thing is, formula we use is again the same. So we don't have to think much about it by which formula to use, or is there any other formula. So formula remains the same. Now we'll see one more example. First we write down the example, that is mean of 40 observations was 160. It was detected on rechecking that the value of 165 was wrongly copied as 125 for computation of mean. Find correct mean. So in this problem it is given that mean of 40 observations is given as 160. But while rechecking, it was found that one observation was wrongly copied. That is, observation copied as 125 instead of 165. It means that the correct observation was 165 and it is wrongly taken as 125. Because of this, the mean we'll get was wrong. So accordingly, we need to find out the correct mean. So how to do it is, first we'll see that mean of 40 observations is given as 160. So first we'll find out the sum from this, because mean is given, number of observations are given. So accordingly we'll find out sum, that is 160 into 40. So we'll get as 6400. This will the sum we'll get for the 40 observations. So now as it is given that instead of 6400, what we need to sum is we'll getting 6400. In 6400, what we need to do is we need to add 165, because the correct observation was 165 and the wrong observation was 165. It means we need to subtract 125. Sorry, the correct observation was 165, so we need to add 165 to the sum we got of the 40 observations. So sum of 40 observation we got as 6400. In that we have added 165, because 165 is the correct observation and we need to subtract 125, because 125 is the wrong observation. So as we have subtracted 125, so accordingly we will get new sum, because we have added 165 and we have subtracted 125. So we will get new sum divided by the number of observations. So number of observations will remain the same. Number of observations will remain the same, because as we are subtracting one observation, definitely we are adding one observation also. So in this case, number of observations will remain the same. So new mean in this case what we'll get is 6400 plus 165 minus 125. So we'll get as 6440 divided by 40. And if we solve it, what we get is 161. So this will be our new mean, or you can say correct mean. Correct mean. So in this way we need to solve a problem by analyzing it. Now we'll see one more example based on this mean. First we write down the problem. Mean of 5 number is given as 18. If one number is excluded, their mean is 16. So find the excluded number. So in the question it is given that mean of 5 numbers are given, that is 18, and one number is excluded from the mean, then their mean changes to 16. So we need to find out the excluded number. So as it is given that mean of 5 number is 18, so mean is 18, sum of observation we need to find out, numbers given are 5. So in this case sum will be 18 into 5, that is 90. So sum is 90 of these 5 observations whose mean is 18. If one number is excluded, so from 90 we are excluding one number, and as we are excluding one number, so let's excluded number be x. So as we are excluding one number, so that means we are doing 90 minus x. So mean of the remaining observations. So as you see that one number is excluded, so the number of observations will remain, it will be 4, because as out of 5 if we exclude one number, the number of observations will become 4. So mean of this remaining observation will be equal to 16. It is given. So 90 minus x, that is excluded number, divided by number of observations, that is 4, and their mean is equal to 16. 90 minus x will actually give us the new sum, because after excluding that excluded number, we get the new sum, and we are dividing it by the number of observations, which will become 4. So we are getting new mean, that is 16. So 90. So if we solve it, what we will get? 90 minus x is equal to 16 into 4. We will cross multiply. So 16 into 4, that is 64. So if we solve it, what we will get? 90 minus 64 is equal to x. So therefore excluded number or value of x is equal to 26. So in this way you need to find out the whatever is asked in the question on by using the formula for mean.